All right, let's dive into something seriously impressive today. We're going to walk through a complete end-to-end MLOps pipeline built for sales forecasting. This whole thing was designed and architected by data expert Elias Andrade, and it's a masterclass in turning raw data into automated, actionable intelligence. Let's get started.
So put yourself in the driver's seat of a huge company like Chevrolet. Predicting which car is going to fly off the lots next month is a massive headache. Doing it by hand is slow, it's biased, it's just plain guesswork. So how do you build a machine that does it for you, automatically and accurately? Well, that's exactly the problem this project solves.
So, here's our roadmap. First, we'll define the challenge. Then, we'll follow the data on its journey into what I'm calling the intelligence lab. We'll watch the model get trained and come to life, look at the whole system architecture, and then, most importantly, we'll talk about the business value of it all.
Okay, first up, the challenge. This is all about making a fundamental shift, moving away from spreadsheets and gut feelings to a system of automated intelligence that's not only faster, but way more reliable.
The technical mission here is crystal clear. The goal was to build a system that can, on its own, grab sales data, use that data to train a predictive model, and then make that model's brain available to anyone through a simple API. The key words here, automated and reproducible, every single time.
As we all know, any machine learning project lives or dies by its data. So let's start at the very beginning of the assembly line and see how the raw materials for this whole operation are created, moved, and stored.
Think of this first stage like a perfectly choreographed three-step dance. First, we need data, so a simulator generates it. Second, an orchestrator, our choreographer if you will, manages its movement. And third, the data lands safely in a data lake, ready for the main event.
So, where does this data even come from? Well, for this proof of concept, it's generated by a clever Flask API. This isn't just random numbers, it's a hyper-realistic simulation of a full year of sales data across 20 dealerships for popular models. It's the perfect fuel for our engine.
Now, you can't have someone manually moving that data around. That would defeat the whole purpose of automation. That's where Perfect comes in. It acts like a trusted, automated courier. It just runs on a schedule, picks up the latest data from the simulator, and delivers it exactly where it needs to go. No hands required.
And the courier's destination? It's a simple, but really effective, passive data lake. Basically, it's a database that has its own API front door. Now, this is a super smart design choice because it keeps the data storage completely separate from everything else. It becomes the one single source of truth that the rest of the pipeline can pull from.
Okay, our data is safely stored and ready to go. We now enter the heart of the operation, the intelligence lab. This is where we'll use a cornerstone of MLOps, a tool called MLflow that turn all that raw data into a genuinely intelligent model.
And this is just beautiful design. The entire machine learning process, and I mean everything from fetching the data, cleaning it, training the model, checking its performance, and even creating reports, it's all handled by one single powerful script. This right here is the engine room of the whole project.
You know, when you're running dozens of experiments, trying different settings, how do you keep track of what worked and what didn't? You need a lab notebook. In MLOps, MLflow is that digital lab notebook. It automatically records every single detail of every experiment, so nothing ever gets lost. It's absolutely essential for reproducibility.
So, let's pop the hood on the model itself. What's the brain of this operation? It's a neural network built with industry-standard tools, Keras and TensorFlow. A really clever choice here is the ReLU activation function. In simple terms, that's a built-in safety switch that tells the model, hey, you can't predict negative car sales. And of course, before any of that happens, a scikit-learn pipeline makes sure all the data is prepped and ready for training.
Okay, the tech is cool, but does it actually work? Oh yeah, the numbers don't lie. The MAE, or mean absolute error, is just 1.83. That means, on average, a prediction is off by less than 2 cars. That's fantastic. And the R-squared score is 0.81, which tells us the model can explain 81% of what's going on in the sales data. This thing is solid.
And here's the best part. The pipeline doesn't just spit out a bunch of metrics. It creates an automated report with actionable insights. This excerpt here in the original Portuguese basically translates to, hey, for month 10, the Onyx Plus is your hot ticket item. We're predicting you'll sell about 315 of them. Now that is something a business manager can actually use. So we've built a really smart model. Great, but a model just sitting on a server is useless. So in this next step, we're going to see how it's brought to life and turned into a live service that can deliver predictions whenever it's asked.
So how do you make sure that only your best, most validated model actually makes it out into the real world? Well, you need a gatekeeper. That's the MLflow model registry. Once a model passes all its tests, it gets automatically registered as the official production-ready version. It's a critical safety net. And using it couldn't be simpler. Another application or a user just sends a request to the model's API. They say, hey, what are the sales for the tracker at this store in this month? And boom, just like that, the API sends back a clean, simple response with a prediction.
And to make sure this thing is always working, the system has its own quality control inspector. It's an automated script that constantly pings the API, sending it little test questions and checking the answers. It's like having a 24/7 monitor, making sure the prediction service is always healthy and ready to go.
All right, we've seen all the individual pieces of the puzzle. Now, let's zoom out and look at the big picture, the entire, fully orchestrated system and how all these parts work together to create a seamless flow from raw data to real insight.
So let's follow the journey one more time. The simulator creates data. Prefect grabs it and puts it in the data lake. The MLflow pipeline picks it up from there, trains a model, and registers the best one. That winning model gets loaded up into a serving API, ready for an end user to ask it a question and get an instant prediction. Each step is its own microservice, which is what makes the whole system so incredibly robust and scalable.
We've spent a lot of time geeking out on the technology, and for good reason. But let's bring it home. What does all of this actually mean for a business? What is the real-world bottom-line impact of a system like this?
The business value here is just huge. Automation means you get rid of manual work and human error. Reproducibility means you can actually trust the results every single time. The architecture is built to scale, so it grows with your business. But the big one is speed. You can go from a business question to a live, working AI solution faster than ever before. This whole project is a testament to what's possible with modern MLOps, and it showcases the architect Elias Andrade's deep expertise across data engineering, BI, and machine learning.
And that really brings us to the final question, a question for you. As you look at this complete end-to-end system, what process in your own company is just begging to be transformed by this level of automated intelligence? Because solutions like the one architected by Elias Andre are the blueprint for solving tomorrow's business problems today.